All right. So we have 11.4, and you can actually kind of see it here this time. Areas of kites and related figures is what that says. All right. So area of kites and other stuff like kites, like rhombi. Right? And I guess, you know what? A square could kind of be related because its diagonals are perpendicular as well. So basically anything with perpendicular diagonals. Exciting stuff. All right, let's hop to it. So let's jot this bad boy down. We've got a new formula. All right, so if it's a rhombus or a kite or even a square, right, our diagonals are perpendicular. All you have to do is 1/2 times diagonal 1 times diagonal 2. Okay? All right, so that is like a little special formula there that'll work with those. And if you think back to, we had a problem where there was a square, I believe, with a diagonal of 12 root 2, right? And what we did is we found this to be 12 and this to be 12, so the area was 144. Well, if you took 12 root 2 times 12 root 2, you'd get 144, and then root 2 times root 2 is 2 over 2. Boom, you get 144, right? So, again, it's just another formula when it comes to like a square. But with kites, you need the two diagonals. That's the only way you're going to get a kite area is with this formula here, unless you break it up into 4 different triangles. All right, the area of a rhombus is 120 square centimeters. If the shorter diagonal is 10 centimeters, find the perimeter. So the area is 120. So let's just draw. Whoops. Let's just draw our rhombus here. Right, all the sides are congruent. Area equals 120. In other words, 120 is equal to the two diagonals multiplied together, right? And 1/2. 1/2 times some stuff. It says if the shorter diagonal is 10 centimeters, so one of them is 10, find the perimeter. So I know that it's going to be bisected, right? So my diagonal out here first off is 10. It's kind of hard to notate that in the diagram. So that's 5 and 5. I know they're perpendicular. Okay. I need the other diagonal. Let's call it x. So let's figure it out. This is going to be, what, 5? So if I take 5x, I divide by 5 then. All right. 120 divided by 5, that's 24. All right, so if this whole diagonal right here is 24, half of that is 12. Cool. Well, that looks like a 5, 12, 13 triangle. Remember, if you just don't forget anything, you're going to do great in this class. All right. So that means all my sides are the same. What's my perimeter going to be? 13 times 4 is 52 centimeters. Boom. That was fun. Let's recap it. So, I knew my shorter diagonal is 10. I know my diagonals are perpendicular bisectors of each other in a rhombus because I didn't forget anything from this entire year. All right, so that means I can split it in half, which becomes 5 and 5. From there, I use my new formula. Got my area of 120. All right, got my area of 120. And I got 1/2 times diagonal. Solve for the missing diagonal, which is 24. Cut that in half because the diagonals are perpendicular bisectors of each other because I didn't forget anything from this entire year. I'm going all the way back to chapter 5. All right, now it's a 5, 12, 13 triangle, which brings me back to, what, chapter 9 when we did the triples. And I didn't forget anything because I remember everything from this year. And now I've got my 4 sides need to be added together, right? Because the rhombus has all congruent sides because I don't forget anything from chapter 5. So multiply those by, or add those all together, or multiply 13 by 4, and I get 50 dose. Whew, fun. All right, let's find the area of a rhombus with one angle that measures 120 degrees and a perimeter of 30 dose. 32. All right, so I've got a rhombus, all congruent sides, right? This is 120. And if I remember everything from this year, I know that my diagonal is going to bisect it, so I'll get 60 and 60, right? I'm going to jot that over here so I don't overwrite the 120. Now, if this is 120, that makes this thing 60 here, but if I bisect it, that's 30 and 30, right? Because the diagonals bisect the angles, they perpendicularly bisect each other. Oh my goodness, I said the word perpendicular. Yes, they are right angles. Whew, looks like I got a 30, 60, 90 triangle happening. What a crazy dealio. The perimeter is 32. If I remember correctly, all my sides are the same. So if I take 32 and I divide it by 4, I'm going to get, what? 8. I'm going to work with that triangle down there. So all my sides are 8, right? So I've got a 30, 60, 90 triangle with a hypotenuse of 8. That's my big sides. That's my big side. That's my 2x side. If I cut that in half, I get 4, which is this guy right here. And if I multiply that by 4 or by root 3, I get 4 root 3 right here. Yeah? All right. Now I got options. Some of you might be like, oh, I'll just find the area of that one triangle and multiply by 4. You'd be absolutely correct. Or I can get my whole diagonal, which is 8. So we'll say D1 equals 8. My other diagonal is 8 root 3. D2, 8 root 3, and I plug it into my new formula, which I'm going to do because we're learning our new formula. So we get, what, 64 root 3 over 2, which is 32 square root 3. It's my area. It's a coincidence that the perimeter was 32 and a 32 appears in this number, or this answer, but sometimes that happens. Feet squared. All right, I like it. And if you're saying, hey, if I forget the units, do I lose points? If you got to ask, just assume it, brother. Yeah, I'm going to take off full points if you don't have units. Oh, my goodness. You know what? If the quiz was out of 20 and you forgot units, I'd give you negative 1,000 out of 20, okay? Because, no, I wouldn't do that. All right, let's find the area of the kite below. If it's a kite, I know my diagonals are perpendicular. I'm going to write that down. I've got an 8, and I got a 10 on that left triangle there. Oh, my goodness. That's a 6, 8, 10 triangle. It's a 3, 4, 5 that's been doubled so I don't forget anything, right? So I remembered that. Woo, chapter 9. All right. Oh, my goodness, I have an 8, 15, 17. It's like they're just throwing triples. They're just throwing triples around, right? This is crazy. So, and I know from a kite that one of the diagonals perpendicularly bisects the other. Well, if this one's it hasn't been bisected, then the other one has to be. So this is going to be 8. Oh, and I remember that from chapter 5 because I don't forget anything. All right, so I get 8 and 8. That gives me 16 for diagonal 1, we'll say. It doesn't really matter which one's diagonal 1 and which one's diagonal 2. Diagonal 2, 6 plus 15 is 21. And I know my area is 1/2 times diagonal 1 times diagonal 2, right? So 8 times 21, basically. So that's what, 168 units squared. Very nice. All right, you guys ready for one more? This problem is just, it's so rude. It's the most rude problem ever in the next one. But let's just double check here, recap. We use our triples to find our missing lengths, right, to get our two diagonals. Our two diagonals are going to hook us up with that area with our new formula for the area of rhombi, kites, and squares. Basically anything with perpendicular diagonals. All right, so we've got a kite, right? So our diagonals are perpendicular. I'm going to jot that in there once again. And I've got other right angles going on here, which is kind of interesting. I rarely see that in kites. I wonder how we're going to figure out, because I got one diagonal, right? Diagonal, we'll say diagonal 1 is 30. I got to find my other diagonal. How am I going to do that? Well, I don't have any other lengths, right? I don't have this guy, so I can't use Pythagorean theorem or a triple to figure out what this one is based off of knowing this. Same goes over here. Oh my goodness. Remember when I said this one was evil? This takes me back. I think it was chapter 9. Altitude on hypotenuse theorem. All right, if I call this guy x for now, just rather than writing d sub 2, x squared is equal to 3 times 21. So 27. So x is equal to 81. X squared is equal to 81. Square root it, x equals 9. Oh gosh, we are just ruthless. Luckily, I didn't forget anything, so I was able to do this problem. And that guy's going to be 9 as well, right? Because the kite's diagonals, one of them bisects the other. One of them perpendicularly bisects the other. And I didn't forget that from chapter 5. So I get 18 for the other diagonal. Woo! All right. Yeah, altitude and hypotenuse theorem. That came back. That one, that was rough. That was the one we struggled with, I believe, on the back page of a quiz with 3 of the same type of questions, all dealing with this, and it was just a bit of a tough one for us. All right, area. Let's finish this guy out. 1/2 times 18 times 30. So I'm going to have, what, 9 times 30, so that's 270 units squared. And there's my area. Awesome. That was exciting and fun. Yeah, you guys, you're responsible for pretty much anything that could ever happen in this class at any given time. That's how you remember things, is continuing to use them. All right? So, we've got our homework, and again, don't pay attention to that bad boy. Dates change, snow days happen, and yeah, all right. Do your homework. Practice it up. America, freedom, rock and roll, and Costco.